Good afternoon, John Cameron here with Pad Print Pros. Wanted to talk today a little bit about TOSH pad printing equipment and the advantages of TOSH pad printing equipment. I've been working with TOSH since 2000. The first time I went to their booth at the plastic show over in Milan, Italy in 2000, I literally felt like a UFO geek with a day pass to Area 51. And it was because I'd been in the industry for a number of years and thought that I knew what pad printing equipment was all about, and this stuff was so radically different and better that I was just astounded. So now, 15 years later, I am still surprised constantly by the things that Tosh is doing. And especially after going to the MPE show here in the US last week and seeing nothing that was new from anybody else, I wanted to make a video to kind of reiterate why it is that Tosh is so advantageous for pad printers. Now, there's a lot of different things about Tosh that make it unique, but number one is the fact that the machines have a modular design philosophy, and that means that none of the machines in Tosh's product line are unitasking. In other words, they're not specified to just sit there and do one part with one set of parameters forever. All of the Tosh machines have a clear upgrade path. That means that they can come in a basic platform and be upgraded or reconfigured to sometimes as many as 10 or 12 different configurations. And when you start with 11 machines as the basic number of platforms they've got and look at all of the different ways you can configure it, you literally have hundreds of potential solutions to pad printing applications that not only can you customize in the front end, but you can reconfigure them to meet new challenges later on very easily, many times in the field and inexpensively. And this is because Tosh makes all of their own part conveying accessories. All of the linear indexers, pad shuttles, rotary tables, eject equipment is all manufactured by and for Tosh. This means that they can take these things off the shelf, plug them in, tell the machine that it's there, and set the parameters. It's not like they have to go out and buy a Casco rotary table or some kind of indexer from someplace else and meld everything together with a PLC. So that modular design, upgrade path, and plug and play accessories that Tosh offers is in and of itself a couple of really good reasons to look at Tosh. Above that and beyond that, there are numerous mechanical advantages. One of the main things is that Tosh has a cast aluminum alloy body. Now, rigidity is a key aspect for accurate, high speed, high quality pad printing. Torque, whip, and vibration that happen in a lot of these other competitive machines that are essentially a metal frame with a bent metal box over the top of it. As they're running, this torque, whip, and vibration that happens within those lesser designed machines, should we say, cause a lot of distortion. Usually that means the operator slows the machine down and you end up babying your machine or babying the process within the limitations of your machine. So a lot of those old numbers that people used to throw out for how fast pad printing can go are really inaccurate because they were talking about machines that couldn't run at the speeds that Tosh machines can run at without vibrating or literally walking across the floor. So when you look at a Tosh machine, you're talking about that cast aluminum alloy body, and every single gram of material that goes into casting that body helps reduce those physical forces of torque, whip, and vibration that cause distortion and make everybody else slow down. The other thing that's huge with Tosh is that they are the guys that pioneered stepper motor drive. Back in 1985, they were the first ones to introduce a stepper motor driven machine to the industry. And they have really pioneered it all the way through from there. There are other electric machines out there now. Some of them are servo driven. I just saw one last week at the MPE show that was incredibly slow, probably a fifth the speed of Tosh, maybe, at probably 5 times the price. So again, Tosh is so far ahead in this field with all electric drives and pad printers that I don't think it's going to be possible for anybody to catch them at this point. Really, being that it's all electric means that you have single plug simplicity. You can move Tosh machines around your factory, and as long as you have the right power and it's clean, you can plug in. You don't have to worry about compressed air and plumbing in all of this stuff and dropping overhead compressed air lines. You don't have to worry about the maintenance costs associated with pneumatics because you don't have filters, you don't have oil and water, you don't have a chiller that you have to maintain, you don't have seal failures, and you don't have leakage. I mean, a pneumatic system by itself, just generating the compressed air, is incredibly costly. And then you probably lose 30% of it from the time it leaves your compressor till when it gets to your machine, because it leaks out of every single thread and connection between the compressor and the machine. So again, just leaps and bounds over compressed air pneumatic machines. And because they're all electric, they're also significantly quieter than any compressed air or pneumatic driven machine. And as anybody that's ever run a pneumatic machine knows, if you lose any kind of pressure because somebody else on that same line turns on another piece of pneumatic equipment, or pressure and volume being equally as important, if you lose any percentage of the required number of cubic feet per minute that machine needs, you're going to see a variation in your print cycle. And with an all electric machine, with a TOSH machine, once you program that machine for the cycle that you want, it doesn't change. Other things with TOSH machines, the linear guideways that they use. Now, linear guideways are rails with sealed bearings that actually roll along them, and you can really achieve a lot more precise linear motion and location with these, because they have about 1/50th the coefficient of friction of a typical slide or other types of mechanisms for guiding, like shafts. And so you have minimal slippage, and this greatly enhances the accuracy of the machine. Not only that, but the rolling contact that the sealed rolled bearings provide have very little wear as compared to shafts and other types of slides. So they can maintain higher accuracy for much longer. And in addition to that, they can also take loads in both vertical and horizontal directions because of the way that they fit over the guideway. And of course, this small amount of friction also means that in order to move the load, you can have a much smaller motor, because you can size the motor for the amount of force necessary to actually do the printing or pick up and transfer the image. You don't have to size the motor to do that and compensate for friction. Stepper motor drives themselves, all TOSH machines are stepper motor driven, which makes them unique in the industry. I don't mean that one part of the process is stepper motor driven, like an indexer. I mean the entire machine is stepper motor driven. That means the motion of the cups or clichés, the motion of the pads, motion of any kind of linear indexer, rotary table, all stepper motor driven and fully programmable. Now, a lot of people want to argue about servos being better than steppers, and the reason why we don't do that is because there's different types of controls in servos and steppers. Stepper and servo motors are similar in that they both have a shaft that rotates at a programmable RPM, or revolutions per minute, to produce a certain amount of force or torque. And servos have closed loop controls, and that means that whenever they're moving and they see some type of a problem, some type of error or obstruction, what they're going to do is they're going to stop until that obstacle is removed, or they're going to time out, or they're going to continue to try to drive through that error or that obstacle to the point where they burn out. Whereas with open loop stepper motors, what happens is when that motor is driving and it sees an obstacle or an error, it simply goes back to the home position and allows you to clear that error and then continue. So it doesn't keep trying to force the issue. That's one of the big benefits. In real life, the only time where you're going to see that type of an obstacle or error in a pad printing application is when you're compressing the pad onto the surface of the cliché or onto the part. Unless you've got some type of mechanical interference and you crash in there someplace. This is precisely at the point in the cycle when you don't want the machine to continue to force the issue. A stepper motor, if it sees that you're overcompressing the pad either onto the cliché or the part, will simply skip the motor or go back and home itself and allow you to make an adjustment to back off on those compression settings so that the machine functions correctly. Whereas it's possible for an incorrectly programmed servo to continue pushing and pushing until it causes damage to either mechanical parts of the machine or the electronics themselves. So that's another important consideration when you're talking about servos versus steppers. Well, technically servos can operate at higher speeds. It really isn't necessary for pad printing. It's another argument that people have, well, servos are faster, and that might be true, but it really isn't necessary for pad printing. And the reason is because TOSH already manufactures the fastest pad printing machines on the planet, without a doubt. And they're doing that with stepper motors. And the speeds that we're doing with TOSH machines now bump up, quite frankly, against the limits of the process with regard to being able to make the ink physically change quick enough to transfer it, and or being able to successfully pre-treat or post-treat parts within the cycle. So we already have plenty of capacity with stepper motors, and the increased speed that we would see from servos really wouldn't be utilized if we were to switch to those for pad printing. Other benefits of TOSH machines, there are numerous mechanical benefits. One of the things is a true U-shaped motion. If you've ever looked at a TOSH machine, normal pad printers, they start pads in a home position. It goes back, horizontal, down, vertical, up, vertical, forward, horizontal, down, and up, vertical again. So it's like a box-shaped motion. And TOSH has a U-shaped motion that provides for synchronous motion between the clichés or the ink cups and the pad. So you've got about 30 to 50% increased efficiency, or 30 to 50% faster cycle speed, just even with a standalone single manual load unload application. Another thing that's very cool with TOSH machines is that they have suspended cliché supports. Most pad printers, if you look at the front of the cliché, here's the front of the machine, and your part's out here. You can't get the part in underneath the cliché support. With TOSH, you have the clichés kind of cantilevered out in space, and you can index parts. If I wanted to print on this mouse, say it's a big washing machine panel, I can index in and out underneath the clichés. I can reach very far in from the outside edges of parts. So those suspended cliché supports are incredibly effective and unique in the industry. The cliché support themselves, TOSH has a flexible cliché support. In other words, instead of having an individual cliché holder that holds only one plate and has its own XY adjustments, let's say, you can have a large plate, and some of them are the size of this desk, where you can put up to 10 different clichés. You can stagger cliché sizes and ink cup sizes, so you could have a 90 millimeter cup next to a 130 millimeter cup next to a 250 millimeter cup with the appropriate size cliché each on each station. So you can maximize efficiency of your machine by reducing the travel required in between color stations, and you can also reduce your consumable costs by using only the size ink cup required to complete the job. We already mentioned that because they don't take any air, TOSH machines are a lot more economically friendly, and also friendly to the ecology, because not only are you going to save, even on a smallest machine, for example, the TOSH Micro 90, next to a pneumatic machine of the same size, 90 millimeters, one or two colors, just on that very smallest of platforms, using the all-electric features of TOSH instead of having to power a compressor and a pad printer, you're saving about $500 per shift, and that's on a very small machine that's using a very small amount of electricity, as compared to the amount of money you would save with a much larger machine printing on a large format part like an appliance panel. So very friendly, not only to the pocketbook, but also to the planet. Some other things that TOSH does that make the machines very effective and keep costs down are that they have their own proprietary controls and software. This eliminates the need for programmable logic computers, which are more expensive and also slower, because they can't always necessarily provide for the synchronous motion that we have with TOSH electronics. Signal has to wait for one thing to stop before another thing initiates, whereas TOSH has synchronous motion with their proprietary controls. Much faster and also easier to program. We already mentioned the upgrade path available with TOSH back in the beginning of my talk here. And one of the things I like best, being a pad printer for 25 years plus now, is the complete cycle control that you have with a TOSH machine. You have speeds and delays programmable in all axis of motion, so you can control each of the 6 parts of the process: doctoring back, pad down at pickup, pad up at pickup, doctoring forward, pad down at print, pad up at print, all independently in whatever increment that you want. On some machines it's in 20% increments, in other machines it's in 5% or 10% increments, or even 1% increment. You can also program delays in, so if you want to have just a small delay before you transfer the ink to allow the ink to tack off a little bit more, you can program hundredth of a second delays in. If you're trying to penetrate or cover a texture that's aggressive, you can delay the pad on the part for just a few hundredths of a second. It makes all the difference in the world when it comes to the print quality, and you don't constantly have to go back and have a science experiment with your ink every time the environment changes. Usually I thin to the middle of the thinner range. If it says 10 to 20%, I put in 15%, set the machine for middle of the range speed, and then it doesn't matter what happens over the course of the day. It can get hot, it can get humid, and instead of having to constantly stop and fiddle with my ink viscosity with a TOSH machine, I can just make a digital adjustment with very little impact to my throughput, to my cycle speed, and really maintain optimal image quality. You have independent transfer stroke adjustments. So even on the smallest of TOSH machines, if you're printing with 2 colors, say with an indexer, and you need to print on 2 separate heights of a part, not a problem. You can program that in there. You don't have any mechanical stops that you have to worry about. It's all digital. The machine has stepping or training motion, so you can actually step it through the process from one color location to another, as well as in and out, up and down, and transfer and print location. And not only can you just step it through by keeping your hand on the button and letting the motor move in slow motion, but once you get to the point where you have the amount of compression or travel that you want, you can hit enter and save it, or teach the machine those positions. It saves an incredible amount of time when it comes to setting up a new job. And then once you have it set up, you can save it. You can save all of those parameters: speeds in each axis of motion, delays, travel distances, pad stroke distances, and you can save it in different languages. The machine speaks 7 different languages: English, French, German, Swedish, Portuguese, Italian, Spanish, and I might have missed one. Finally, they're incredibly easy to automate because you can sync these with other TOSH machines in a master-slave type of a relationship. And if you have to use a PLC, in the case of integrating one of these machines onto an existing production line, or building an automation where you've got a bunch of other stuff going on for assembly or pre or post treatment, it's incredibly simple to do that. You just plug the machine into the PLC, give it a signal, PLC tells it when to go, done. And finally, there are numerous counters on there that can help you see what your operators are printing per hour. You can have countdown timers if you want to print batches. Just all different kinds of things that are just standard equipment in a TOSH machine you can't find anywhere else. So, contrary to what a lot of people say, all pad printers are not the same. Anything but. The TOSH's features make impossible jobs possible, jobs that are marginally possible standard, and those really easy jobs serious money makers, because you can go so much faster than you can with anything else. If you're not accounting for real bottom line production costs when you're looking at the cost of a pad printer, you're going about it all wrong. TOSH is going to cost a little more. It's going to cost more than a piece of Chinese pneumatic equipment. And if at the end of this whole presentation you don't understand why, then I wasted my time. What you really need to do, though, is get with us. We're more than happy to work with you and provide a thorough cost analysis. What's it actually going to cost you, side by side, apples to apples, or apples to oranges if you're really going to go that route and buy some old pneumatic machine. We'll set it side by side and show you, including capital costs for both TOSH machine, any competitive machine, over the life of a program, what it's actually going to cost you to run anybody else's equipment, and how much money you're going to burn using anything but TOSH. And I'll show you the math. I'll go through it with you in shorthand if you want to. So you can contact me. It's John Caverman with Pad Print Pros. You can reach me at my website, which is www.padprintpros.com, or by email at padprintpro gmail.com. Again, I appreciate you watching this video, and I hope that you found it helpful. Thank you.